In this episode of FUM0102 machining, we are making some fasteners, bolts to be exact. These are like this. Of course you can buy the fasteners for your local hardware store, but in some cases you need to make those because it is there are several reasons. For example, you would like them to look better, maybe some modeling or something like that. And then in my case I want to attach a grease fitting here. Thing like this is a very small grease fitting. So this one, if I drill a M6 hole from this side, it weakens the bolt in a way that it's no more usable. But if I lengthen this part so that the thread ends before the flange, then it's good to go. So I need to make two of these. So we go and make these mainly in the lathe, but there is also some milling to do for the hex thing. But let's go on with these. This is stock. It's cold rolled steel and it's 60 millimeters in diameter. The reason why I'm using this is because I'm going to replicate this one. And this is, if you measure this one from edge to edge like this, so then you get something like 15 millimeters. Okay, so there is 1 millimeter extra. Well, we leave it there. We don't reduce the diameter here at all, because in the milling machine we are going to do this hex. It's going to be in the other end. Well, the dimensions in the lengthwise, they are like this portion of thread seems to be, in my case, 18 millimeters. Okay, 18 millimeters M8 thread. Then we are having a flange about 6 millimeters. Okay, and then as we need to create the M6 thread for this one, this is the grease fitting. So this also needs 6 millimeters. So it's 6 plus 6 plus 18. Oh, that's 30. So 30 millimeters stick out minimum plus the amount needed for parting. So if we put here like 30 and see, well, we have about 10 millimeters here, so it's okay. So the order of operations here is actually a little bit critical. If I just decide to reduce this to 8 millimeters for M8 thread, then thread it, well, how could I hold it after that one? Because I need to do some lathe operations after it has been sitting in the milling machine. So I leave the thread itself as the very last operation here. What I'm now doing is, because this is for grease fitting, there should be a hole through this one, which can then squirt the oil into the pin. So I need to drill a hole through this one. Okay, so therefore the first thing I will put a little bit of a center there with this thing. This one is, when you put a center like this, well, I have been saying this quite often, you want to, or you don't want to drill it very deep, just enough so that it centers the drill. If you do it all the way, it will be like the angle of this thing is totally incorrect for a drill bit. But the very tip of this center drill is correct actually. So let's switch the machine on and do some center drilling here. This is, and again I place it so that the groove is facing up, so I can squirt my cutting oil into that groove. So I use quite slow RPMs here because I don't want to break this drill. Let's see now. And this really doesn't need to be very large. That's okay. There you are. That's more than enough for our purpose. There is a, well, I already faced this one. So now, well, we are going to use drill bit like this. This is, well, maybe you see, maybe you don't. This is very slim. It's a 2 millimeters drill, and I'm going to drill it all the way through this 30 millimeters, but not all the way through, because there will be, if I drill it all the way through, and then when I cut it, there will be a remaining hole on the next piece, and this is probably not in a good center. So therefore I leave a little bit shy this hole, so I don't go so when I cut it there will be a fresh surface, because we need to drill it the other way for this oil fitting. So therefore I leave it something like 5 millimeters shy. So now I could use the tailstock for this one, but I don't want, because we need to do back drilling here. So what I use is this and this and this. So I will attach it here like this, but I need to put it, here is a groove inside there. So I need to put the drill here like that, and then this is just to make my living a little bit easier, and then I just tighten it there like that. See that it's in the groove correctly. It is. Yeah. Then I tighten it there. This doesn't need to be super tight, but it needs to be straight, so I check that it's sitting on the bottom of the groove, and these need to be really clean when you do this. Any cuttings there will misalign it, and that's not a very good idea, because you cannot adjust this kind of alignment. So therefore it needs to be clean and straight. Okay. Well, now becomes the interesting part. Since we need to align this both for height and oh, this machine needs to be bolted in the table. I believe it's going around every time. So I'm using the this hole here to align it. There you are, the correct height, and then I lock it, and then I put this there. And then I see if we can repeat. Yes, we can repeat. Okay, now this part of alignment is now done. Then the next part is to make it straight this wise. And for this we are going to use the chuck. Please note, I locked it already there. So now when I come here, I come all the way through like this, and then I go near. This drill is really flexible. What I'm using here is the reflection of the there you are. Well, I believe now it's straight this way, it's straight this way, and it's in correct height. So now the only thing we need to do now is to put this in correct position this way. But well, we need it to go down 30 millimeters minus 5. So what I'm using is the, let's first measure this one. I'm using the hand wheel in the back side of the lathe to put it somewhere in the vicinity of, and then I just turn, because we need it, well, we need it 25 millimeters. So 24 is divisible by 3, I believe. Is it? 27 is 9 turns. Okay. Which way should I turn this? Again, not that way. Oh. Okay, there you are. So 9 turns. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9 turns. The backslash away. 9 turns exactly produces us 27 millimeters. So we are 3 millimeters off the total 30, are we? Yeah. Well, that's enough. I could leave it that one, so we leave it there. So now, what we do here, I have a stop like this. I will put it there now. There you are. I made a stop for this thing a while ago. This is not a good one. It doesn't work very well. I need to redesign this one really. I think this well, it never works well. I don't know why. I think there you are. Let's see. Again. There you are. 27. Like that. Well, there it is. Okay, it's in the correct place. And now we center it. There you are. Now, why I'm doing it with it, not with the tailstock, but with this cross slide, is because I'm doing peg drilling, and this one is really tedious with the tailstock. So therefore we do it with this one. I think this one benefits from really large RPMs. So let's see now how I break a drill. It's very flexible, and you should be really careful when drilling with these. Now you understand why I'm doing this with this cross-slide. This would be a nightmare with tailstock. There we are, 27mm deep hole. And now I'll take this away and I don't take it away from here, it's already aligned everything. But well, of course we lose that one during the next operation. Well, the next operation will be to reduce the diameter for the threaded part, which was 18mm. So we need to have this there. Let's loosen this one a little bit and go like here. Just because none of these dimensions is really critical. So now I need to go in for 18. It's 3 times 6, so 6 turns. Which way? That way. 6 turns. 6 turns. Oops. Like that. So let's see. It should be now 18 millimeters, quite exactly. And it is. So now we place the stop again here. Yeah, and now we have it stops in well, in 18 millimeters there. So what we need here is a cover, because now we are getting a lot of cuttings. We need to, because if they go in between there, between the stop, it will actually make this thing to misbehave. Okay, I think we have it there. So now this lathe is capable of, and this tool is capable of taking cuttings in 1 millimeter depth, and if you feed correctly, you also get good chip control. So That's about the correct speed. Let's see. That would be alright. So let's touch first. There you are. And we need to take away, because it was 16 millimeters, we need to take, 16.6 plus 2, 8 millimeters away. So let's take the first millimeter. That's first. Second. Third. Now it's 6, so it should be quite exactly 10 millimeters. Let us see. Oh man. Well, it is a little bit over, but that's okay. So now 2 millimeters to go. And this diameter is the... oh, it's hot. This diameter, let's see if we have any chips there. No. This diameter is the major diameter of the thread, so, well. I speed it up a little bit. So, okay, now half a millimeter. And now a little bit slower feed. Well, the finish is not good, but it doesn't need to be in this case. And now, like that. And there you are. I think it's, well, it's not beautiful. Well, it's beautiful enough for me. Let's see, this is now 8.1 millimeter. It's okay. So now a chamfer here for the thread. I'll loosen this one so we can use this thing. We don't need the stop anymore. Take it off. Okay. Yes. And now let's see where we were. We need to chamfer about 45 degrees here. So let's see. A little bit more. There you are. And then I touch that corner because it's very sharp. I don't want to hurt myself with that one. There is a safe edge here, so I don't. And I see really many machinists do that when it's turning, they already touch this. And that's dangerous. You can get yourself hurt. Because if it's not good, then you get hurt. Okay, the chips were not that good as I expected. I expected to get the little ones in this case, but okay, they are. Normally I get really small ships with this tool bit. Okay, now we are almost there. We need to cut it now, part it. And this one will be now at 30 millimeters. And for this one we need a little bit less speed for the first. Then we need the cutting tool, parting tool I mean. And there you are. And this was already straight, really. So now we need the 30 millimeters. And this is again not a critical measurement. So let's see, 30. There you are. 30 millimeters is about there. Lock the crosslight. This is important. And also lock this compound as I loosened it. If it's not locked, there will be vibrations, really violent vibrations around. So now let's part it. I take the tailstock as a support for my hand. This one has some. Okay. Let's see now. A little bit faster, I believe. Oh, it should be faster anyway. So let's put the next gear on. I believe this is good. It's still trying to vibrate, even though I have it quite. And I succeeded in not creating a hole there. So now I just make another one which is exactly like this one. And there you go. Ready for the milling machine after that. That one can be, I file it away. Okay. Next. Yeah. So now I have made two of these pieces which are almost identical. Well, you cannot eyeball them to be different, but they are almost identical. The next thing to do is to put a hex here. 13 millimeters for a 13 millimeter range. Well, for some of you this is like well, a very simple thing to do. Yeah, it is. And well, I'm using my dividing head for this one, and well, a milling machine. So I'll get you a little bit closer so you can see what I'm doing here. I have already centered this one, dialed it in with my dial indicator setup. It was attached here like that, oh, like that, and then I just rotated it, and well, now it's within 1/100th of a millimeter. It's really nicely there. So what I will now do, because this we need to have 6 millimeters of hex on top of here. So I will touch the this surface, meaning this surface here, and then come back 6 millimeters. As simple as that. And furthermore, and then I of course lock this table to that position. And after that I will touch the top of this one, and then, because the diameter is now 16 millimeters and our target is 13, I will take 3 millimeters out of the diameter. Means 1.5 millimeter each side. And it's a good practice when you are doing a hex. So actually this 13 millimeters is a maximum. So I put a hair more so that there will be some playroom for the wrench. So now I switch this thing on. There is this big ass switch, and now well, let's put the speed in correct first. Oh, there is coming oil. This is always after it has been sitting and I oil it, it will throw oil around. Okay, well, this is not enough speed at all. We need to change to higher gear. Like that, and now let's see. That's alright. You can see, maybe you can see it, there is a very small cutting there, so this means that we only need to go 1.5 millimeters. Now we have the playroom there already. So I zero this, and then I come up 1.5 millimeters, which is actually one revolution from this. Oh yeah, there you are. Okay. And then now we have everything correct here. So I will be hand feeding this. But before we can do any feeding, we should put this into 0. There is this indexing thing. I'm using direct indexing here now. And then, very important in this one, lock it. Okay. Then we also need cutting fluid. And then we just go on. To 60 degrees. 60. There. Lock. 120. There you are. I believe. Should be there. Let's see. Well, looks like it looks good. Does our wrench go there? Yeah. Is wiggly as it should. Ready. Well, it's always a good idea to press the record button on your video camera if you intend to take videos. I forgot to do that, and therefore you lost my babble about how to center this thing here. Nothing more. Okay, now I will face it. Yeah, just face it. Well, that was simple enough. Yeah, it's faced. And then I will do 2 chamfers there, actually. There is a lot of burr here. I will make a very little chamfer there, and then I will chamfer those corners. I believe I have been parting with a loose compound. See how it looks? Nice. It's there. And now we will do some drilling. Let's see now. We need to see that we can do this. Yes, we can. It's free to spin. Always check that one. Never ever trust your feeling with that one. Ha! I have succeeded in bending this one. Let's see if we get fluid out from there. Yeah, still flowing. I think I bent that one in the middle. So we make a very tiny hole here, just a place for the drill to start. There you are. So now the drill doesn't wander around. The original depth of threads was 6 millimeters. So, and because there is some taper, this is a black tap. So we need to add something to that. 2 millimeters. So now it's 3 plus 6, it's 9. Let's see how much we have. Just eyeball. If we have 9 here, well, it leaves quite good margin for the fans, for backside there. So we can drill it 9 millimeters deep. So that's exactly what we are going to do now. 9 millimeters it will be. Let's see the speed. Okay. I need to fix that one. 9 millimeters. It should, yeah. Now I'm in the 2 millimeter hole. I can feel it already. So 9 millimeters here. Wow. A little bit more. Now it's 9. Okay. Come back. So now what we are doing next, we will make some threads there. This one, I made this a while ago. There you are. Let's make some room here. Okay, let's see. It's still a little bit. And I put it all the way there. Yeah, okay. And I come here with this one. Okay, now let's make the threads. So this is M6 plug tab, spiral flute, and there is not much to go here in this case. We need to be really careful. Okay. This needs to be all the way down, really. Otherwise the oil fitting doesn't go there as it should. Okay, a little bit more. I think we are there. I will check this out when I get this thing out from there. Wow. Ah. Oh yeah, let's see. Let's try it out. Here is the oil fitting, which is supposed to go there, and it goes very nice. Okay, number 1 is ready, and number 2 will be similar. Now the last step is to put an M8 thread into this piece. I'm going to use this die, and I'm going to use the drill chuck to keep it straight. There is also already a chamfer which we make there, and I already have dialed this in the center. Okay, so well, this is just doing the thread itself. Needs some lubrication. Also that one. And then we come from here to there, somewhere. Very little room here. Maybe there. Okay, let's see if we have enough tailstock reach. Yes, we have. Okay, now let's start. A little bit more. Just a little bit more, I believe. Well, I can get this away. And let's now what I will do here, just to get some visibility here, I will turn this around. Well, this didn't feel good. It was a little bit tight. Okay. put some stuff there too. Now I have a better visibility how much thread I'm at the moment. A little bit more. That's more than enough. Yeah. Well. Yeah, our first bolt is done. And now since, well, it, well, yeah, looks like a decent bolt. With threads and all. Yep. Next in. Okay, let's see now how these fit together. I already tried it a little bit, so I know that this needs to be this way, and this is, you can hear, you can blow through it, so it goes like this here. Then we have this oil or grease nut bolt coming from this way. Goes really good there, hopefully. Seems to be a little bit, is there some burr somewhere? Shouldn't be, oh yeah, we had. Okay, that was the reason for that. Because it should go right on the, yeah, now it's okay. And this side then. So now, as you see, this is here quite in the middle. So now just tighten these, and if the pin is of correct size, it doesn't matter, it shouldn't become any tighter when I tighten these. It's about 1/10 of a millimeter longer than this hole. But let's see what happens when I tighten this. That's tight. That's also tight. Ta-da! Yeah. And the amount of play, well, it's about 1/2 millimeter. But it's straight in place, and yeah, okay. And you cannot, it's really this way, this kind of wobble you have some, but not a lot. Okay, and this one is the next. Okay, goes this way. And then we have this on top of here. Well, this goes really easily. Means that this is quite straight actually. And this one doesn't go. Why? You need to bend it a little bit. Why? Aha, okay. Now it goes. And this one should be similarly loose, and it is. Okay, now we are so far that this is actually quite, it's already somewhat working unit, but we need to do something for it. And here at the end, the play is about 1 millimeter. So that's the worst possible position when it's all laying down here. So the worst thing, it's about, well, it's a millimeter play here at the end, and that's really good, and it will somewhat become smaller when I put grease into those. Not a lot, but it will be not so notable. And then these oil fittings there, 2 of them. And that's definitely there. That as well. Maybe a little bit more. Well, I don't want to destroy the threads on these. Okay, I believe they are tight enough. They are not high tight. Yeah, okay. Well, the next thing is to put a hole into this one in order to get the grinder attached to that one. So, sorry about this, we don't have not yet the actual grinding happening in this video, but it sure looks really good at the moment. Maybe I probably will paint this one. Well, if it is worth a video, yeah. And then now I promise next video will contain actually using this for something. Just to cut some steel and we see if it works or not. Actually, I don't know whether this is a good idea or not. It might be really bad. It might be horrible to use. I don't know. That one we will figure out in the next episode of FUM0102 Machining. Till then, bye!